first page on lesson 5.2 that I thought were kind of important, so you might want to do the same thing. This is the kind of stuff that might show up like on a UT exam or something like that. But they made a big deal about this part about a limit enables one to describe much about the behavior of a function without actually graphing the function, even at values where the function does not exist. So I thought that was kind of important. You may want to underline that or highlight that on your packet there. That's kind of a big part of this. So as we talk about a limit, there's two different things that we're going to talk about. And this is kind of the note that I made up here to myself if you want to jot this down somewhere. A function, so if I ask you for like the function value at 2, that's like a picture of what's happening at that one point. Okay, whereas the difference is a limit is more like a movie. And we're going to look at kind of as it's moving, what's happening around that one point. Okay, so that's kind of the difference. A function at 2 is the one point, what's happening right there. Whereas a limit is going to be what's happening around 2 as we get closer to 2. And as I talk about that value, that's going to be your x value. Your answer is going to be your y values. Okay, so that's kind of the difference between a function point, which you've worked with a lot before, and a limit. Okay, so if you want to make a note about that to yourself, that might be good too. The other thing that they made a big deal about is that a limit describes the behavior of functions for any value of the independent variable, including very large values. So when they talk about very large values, they're talking about things that happen like into infinity and into negative infinity. Okay, so this is a good way to look at like what happens as you go off into infinity and negative infinity. Okay. Like on those rational graphs that we've just been talking about, a lot of them come and like hit that x-axis and then go out forever and ever and ever on the x-axis. So those are limits that are approaching 0. Okay, so we can talk about things that are happening in very large values like that. Okay, all right. The other thing that they made a big deal about is down here at the bottom. When you're looking at this function that they gave you, it says that f at 4 yields an indeterminate form of 0 over 0. So we've talked about things that are undefined having 0 in the denominator. But if you end up with 0 over 0, that's actually what you call indeterminate, is what they call it. So that may be like a new vocabulary word for you. Okay. So we're going to be looking at a lot of these graphs. If you look at the function that they've given you down here at the bottom, and I take out the x minus 4, I'm just now graphing a line at x plus 5. Okay, that's really what I'm doing here. So let me show you on Desmos what that looks like real quick. So here's my line. If I were to graph that function, the x minus 4 over x minus 4 is going to cancel out. And now I'm just graphing the line x plus 5. So if you think back to a y equals mx plus b form, I've got a y-intercept of 5, and then I've got a slope of 1. Okay, so that's really what we're looking at here. And Desmos doesn't do the pixels very well, so you can't really see the whole. But because I canceled out the factor at x minus 4, there's actually a hole in our graph right here. And we're going to look more at a hole here in just a second. But there's a hole in your graph right there at x equals 4 where you have what we call jump discontinuity. Okay, so if I was looking at the function value, I wouldn't have one. There's no function value at that point. But there is what we call a limit, because as you get closer and closer and closer to 4 on the x-axis, you are approaching the y value of 9, okay? And because you're approaching that same value from both sides, it does have a limit, okay? So that's kind of, again, the difference between a function value and a limit. Okay, so they give you an example here on your packet of if you plug in 4 originally, let me go back to that. If you plug in 4 originally, it would give you that 0 over 0, but once you've canceled out, I can find the limit, because if I plug in 4 plus 5 is going to give me 9. Okay, so we can't find the function value, but we can find the limit. Again, just a little bit different. Okay, so flip over on the back side, and we're going to try exploration 5.2.1 today. So take just a minute and try numbers 1, 2, and 3, and then you can check your answers as you go there. So see if you can graph number 1. It's going to have a hole and be a line. So give that one a try. And then see if you can work on 1, 2, and 3. So work together. See if you can figure those out and check your answers. Just on the back side. On the exploration. Okay, so on this one, my x minus 3's would cancel out. So really what I'm graphing here is x minus 9, but I'm going to have a hole where I have an x value of 3. So to find my y value, I'm going to plug in over here to this. So if I do 3 minus 9, that gives me negative 6. All right, so I'm going to go and graph that. And I got a couple of things I can graph here, but I know that I'm going to go over here to 1, 2, 3, and 1, 2, 3, 4, 5, 6. And I know I'm going to have a hole right there, so that's 1 point. I'm just graphing a line here, so I really just need 2 points. So I went ahead and went out and did my x-intercept. You could do your y-intercept if you wanted to, and then do your slope of 1. It's completely up to you. I did the x-intercept, so my x-intercept is going to be at 9, because 9 minus 9 gives me 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Gives me a point right there. So here's my graph. Like that. Yeah.
Where did you get the negative 6 from?
The negative 6, I plugged my 3 into my now reduced equation right here.
Oh.
So 3 minus 9 gave me that negative 6. Yeah, good question. Yeah, so anytime you're finding a hole, even when you're doing the rational graphs, plug in your x value, but don't plug into the original, because if you plug in the original, you'll end up with that indeterminate, that 0 over 0. Mm-hmm. So plug always into that reduced equation over there. Yeah, good question. Okay, so if we characterize what's happening with f of x is equal to 3. So as I look at my graph, and this is kind of what we're going to do with a limit, I'm going to come from the left, moving this way towards this hole right here. And I'm going to say that my y values are getting closer and closer and closer to negative 6. All right, then I'm going to come from the right and go left towards that point, and I'm going to say that my y values here are also getting close to negative 6. Okay, so what's happening at x equals 3 is that there is a hole at that point, 3, negative 6, and again, that's what we call jump discontinuity. Big word. Okay, and we call it jump discontinuity. If you think about it, if I was going to draw this line, just, as a line here without the points, whatever, I would draw my line. I would need to pick up my pencil and jump over that hole and then keep going over here on the other side. So there's different kinds of discontinuity. One of them is called jump discontinuity. That's what you have when you have a hole right there. Very good. All right, so explain how the value of the limit as x approaches 3 of f of x is connected to the graph. Well, you could say something to the effect of, again, as those x values are getting closer to 3, the y values are getting closer to negative 6. Okay, so as the x values are getting closer to 3, the y values are getting closer to negative 6. Let's say from both sides. Let's make a big deal about it being from both sides, because in just a minute you'll see one that doesn't come from both sides, and that's going to have a different kind of answer. Okay, so again, as the x values are getting closer to 3, the y values are getting closer to negative 6 from both sides. So if I come at it from the left or if I come at it from the right, I'm still getting closer and closer to that negative 6. Okay, so what that is, again, is a limit. And in this case, I could cancel out one of my factors and be left with something that if I plug that 3 in, it would give me an answer. Okay, so here's what it's going to look like. I'm going to have this little word limit, and then it's going to ask me, as x is approaching 3 of this function, what is my limit there? So what you're going to want to do is cancel those out, plug the 3 in, and say that your limit is negative 6. Okay, so if it asks you for the limit as x is approaching 3 on this one, your answer would be negative 6. Okay, any questions on 1, 2, or 3? Kind of a weird idea. Okay, on number 4, we get into a function that doesn't have something that can cancel out. Okay, so there's no factor on the top and the bottom of number 4 that we can cancel out. Okay, so instead I'm going to use a table like I did the other day to find out what my limit is. Okay, So I'm going to look at some values that are around positive 5. And I'm going to look at around positive 5 because that's where they ask me what the limit is. For example, if I plug in 5 to this, I end up with 0 in the denominator, which again is not okay. All right, so I'm going to build a table instead. All right, so let's go through the steps to build a table again. I'm going to go in my calculator. I'm going to go to y equals. Clear out anything that's in there. All right, to put in my fraction, I'm going to do alpha F1, number 1. I have a couple of yellow calculators, by the way, that the alpha F1 number 1 isn't working. So if you have one of those, just trade out and get a different calculator. I'm not sure why that's happening. All right, I'm going to put in my 1 over x minus 5. Okay, so alpha F1 number 1 is put in my fraction. Okay, and now let's go back to table set and just make sure that my setup is still the same. So go second and window, second table set, right here. Right, so second table set. And let's see here. Let's start our table on this one at 4 because that's my first value in the table that they've given me. And again, we need to set our independent over to ask. Let's write that down. So table start, oops, why did I write a P? I don't know. All right, so table start needs to be like your first value. In this case, 4. Okay, and then don't forget to set your independent to ask. Okay. Now your dependent needs to be auto, otherwise it won't give you answers. So watch out for that. Okay, so now I'm going to go right here to table, right here above graph. So go second table. All right, and I'm going to type in all of these numbers right here. So I'm going to type in 4 and 4.5 and 4.9. and 4.99, and notice that they're picking values that are around 5, because that's what they're asking us about. All right, and at some point the table kind of runs out of space, so you may have to write some down and then go back. It's right there, it misses 1. It won't keep going. If you type in the 5.5, it types over the 5.1, so anyways. Okay, so let me write these down over here. So -1, -2, -10, -100. Okay, we know it's going to have an error right there because that's where my asymptote is. Make a little note of that. Then 100, and let me put back in my 5.1, 10, and 5.5. So again, they might not give you the x values to put in, so kind of keep a note of that, that as if we're looking for the limit as x is approaching 5, they've put in numbers that are around 5. So if it was asking me about like 3, I would put in 2, 2.5, 2.9, 2.99, 3, 3.01, go from 3 from there. Yeah. Good. Okay, so what we're looking at is the behavior of f of x as f approaches from the positive side and from the negative side. Okay, so this up here is what they're going to consider the negative side. Even though the numbers aren't negative, it's like I'm coming from my negatives in 0. So think about that being on the x-axis. Okay, and then, excuse me, these down here is what's going to be your positive side. Okay, so even though they're not positive and negative values, that's the side that you're coming from. Okay, and what that's going to look like, as it asks you about the limit, it's going to be x approaches 5 from the left is going to look like that. It's going to have like a little negative that looks like an exponent. Okay, so that right there means from the left or from the negative side. Okay, Okay, so from the negative side, this thing's getting bigger and bigger and bigger and is getting closer and closer and closer to this negative 100 right here. Okay, so as it's coming from the left, I'm going to say it's approaching negative 100. So this is this side right here. Okay, I'm getting bigger and bigger and bigger, and I kind of stop right there at negative 100. Okay, let's go from the right. So this time, I'm going to have the limit as x approaches 5 from the right side, or the plus side. Okay, so that's what that kind of looks like. Again, that means that we're coming from the right of my function. Okay, so as I come from this side, I'm getting bigger and bigger and bigger, and I stop at positive 100. Okay. If they are the same, then you have a limit. If they are not the same, then you can say that the limit does not exist. Okay, so in this case, this one's negative 100, this one's positive 100, so they are not the same, so I'm going to say that my limit as x approaches 5 of my function, and I'm going to put DNE for does not exist. Okay, so you only have a limit. I said something that Siri likes. Sorry. You only have a limit if the numbers coming from the left and the numbers coming from the right are the same. Okay, if they're not the same, you can stop and say it does not exist. Okay? Questions on that one? These are kind of weird. Okay, let's skip over number 5 for just a minute and go to number 6. And that was good timing. And let's take a look at this picture right here. Okay, so this is kind of a picture representation of what we just did on the table. All right, let me find a blank one. Oh, here it is. Okay. All right, so what I want to know is what is the limit where x is equal to negative 1. And I'm actually going to also add to that to also find the function value at negative 1. Okay, so let me add to that question. So we're going to find the limit and we're going to find the function value. Okay, so remember the function value is a picture, the limit is a movie, what's happening as you move from both sides. Okay, so that's the difference. Okay, the function value is going to be, so f at negative 1 is going to be where the solid circle is. Okay, so I've got two types of circles here. I've got an open circle and I've got a solid circle. Do you see that? Okay, so here's my open circle right here. Here's my solid circle right here. Okay, remember that we're always answering with y values. Okay, so they're going to give us the x value. We're going to answer with a y value. Okay, so on this one, if I'm looking at an x value of negative 1, where my solid circle is, what's my y value? 0. That's right. Good. So my function value answer would be 0. Okay, here's my solid circle right here. It gave me an x value of negative 1. I'm going to answer with the y value of 0. Okay, but now to look at the limit, I need to move along my lines, and to do that, I'm going to look at the left side and I'm going to look at the right side. Okay, so let's start with my left side. So I'm going to start by finding the limit as x approaches negative 1 from the left of my function. Okay, so again, that little negative up there in the exponent means to come from the left. Okay, so I'm going to use a highlighter. And my graph on the left, so here's the left-hand side of my graph over here. All right, it's right up here. And I'm going to come down my graph from the left. And what y value are we getting closer and closer to? 2, that's right, good. Okay, now I'm going to move over to the other side and I'm going to find the limit as x is approaching -1 from the right of my function. Let me get a different color. Okay, so this one was my left. Okay, let's see if you can see yellow. Let's see. Yeah, we can kind of see that. Okay. All right, so now I'm going to come from the right. I know it's the right because of the plus sign right here. So over here is the right side of my graph. So I'm going to come on my graph from the right. What y value am I approaching as I come from the right? 0. That's right. Good. Okay, are they the same? No. Okay, so I got the left side was 2, the right side was 0. If they are not the same, then I can say that the limit as x approaches -1 of my function does not exist. Okay, they have to be the same number. So if the right-hand side had also been 2, then my limit would be 2. Okay, but since they were different, my limit does not exist. So my function value existed, but my limit did not. Do you see the difference? Okay, so the function value again is a picture. The limit is the movie. The limit is what's moving. Good. Okay. Let me give you a minute to try number 7. Number 7 goes back to one kind of like number 1. If you factor that, some things will cancel out, and you'll be able to plug in your value of 1. Okay, so give number 7 a try, and then we'll come back together for number 8. Number 8 is kind of hard. Plug in 1. Yeah, plug in 1. Plug into your reduced equation. You don't. You don't have to graph. You can if you want to. So this one you can actually just plug in, right? So you don't really have to do a left and a right on this one. Once you get to your reduced equation right there, so check your reduced equation. Once you get to your reduced equation, I can plug in 1 and not get a 0 in the denominator. So you only have to do the left and the right-hand side if you're working on a table and a graph, because your denominator when you plug in gives you 0. That's when you need to come from the left and the right. If you can reduce and then just plug straight in, I'm going to say now that I've got 1 plus 2 on the top and 1 minus 2 on the bottom. So I'm going to say that my limit is negative 3. Okay. If you want to graph them, you can. That's perfectly fine. Or if you want to look at them on a table. But these that'll cancel out. You can just plug in, and then you don't have to go through the extra work.
So how do you know, how do you know it's going to be the same from both sides?
On this one, because when I plug in, it doesn't give me a 0 in the denominator with my reduced equation.
So if it's giving you 2, yeah.
Okay, as opposed to, let me show you the other one. Back to this one, I couldn't reduce my equation on this one. So if I plug in 5, I'm going to get 0 in my denominator. Does that make sense?
Yeah.
Okay. So when you are given a graph like this, or when you have one that it won't reduce, that's when you have to look at the left and the right-hand sides to see what's happening. If it'll reduce and it doesn't give you 0 in the denominator, then you can just plug in and find it. Yeah, good question. Okay, we can look at this graph. This is what the graph looks like if you want to just look at mine. Looks like that. Okay. This actually gives me a good time to say, so on this one, if I was looking from the left, I'd be approaching negative 3. And from the right, I'd be approaching negative 3. Okay, but let me ask you a trick question. What's the function value at 1? Yeah, that's right. Yeah, undefined, or I'm just going to write D and E for does not exist. That's right. Good, it is undefined. There's not a solid circle or a solid point where x is equal to 1. So since there's no point or no solid circle, then your function value is undefined. Very good. Good. Does that make sense? You kind of see the difference between the two? Okay. To me, that's the hardest part of all of this, is kind of seeing the difference between a function value and a limit. Okay, let's work on number 8 together. I think this one's kind of hard. I'm going to start by reducing my equation. If you're going to set these equal to each other, be sure that you keep writing that word limit. If you want to go over on the side and work, that's okay. But I know when we graded the AP exams one year, we had a bunch of people stop writing this limit, but they kept saying that they were equal to each other, and they're not. And so they took off a bunch of points for that. So if you're headed to calculus next year, just be sure if you write equal on these that you keep writing limit as x approaches 2, limit as x approaches 2. Okay? The trick to it is to go over on the side and not write that they're equal to each other, and just work on the side and then come back to this right here. Okay? Yeah. They're really picky on that AP calculus test about setting things equal that are not equal to each other. It's a big deal. Yeah, I reminded you about something today too.
Yes. I got points off on my test for not running.
That's right.
I wrote equal to the limit for one step, and then I simplified it and wrote equal to, and didn't write the limit.
Did the simplified?
And then my answer had the limit or whatever. But
right.
I put equal to, and I got points off.
That's right. That's right. That's because that's what they'll do on the big AP test. Yeah, that's right. Good. Okay. On this one, I'm going to simplify first. So I'm going to put together what I have up here on the top first. And so, again, if you are good at finding common denominators and you want to go with that, that's perfectly fine. Again, the trick that I use is SMILE. Okay, so if you want to keep using SMILE, you can. I'll show you that again. If you're good at common denominator, run with it. That's perfectly fine with me, too. Okay, but to use SMILE, I'm going to take my 1 and multiply by my 2. So that's going to give me 2. I'm going to keep the sign that's in between them, so minus. And then I'm going to do the x times the 1, which gives me x. And then I'm going to find my common denominator by multiplying these things together on the bottom. And that's what makes my smiley face. So 2x. And then I still have x minus 2 down here on the bottom. Can you read that one on the bottom? The bottom one says x minus 2. So I kind of ran into the next one. Okay, so if you need help finding common denominator, that's just a really quick little easy way to do it. So multiply top times bottom. Keep the sign that's in between. Multiply bottom times top. And then multiply the things that are on the bottom together to get your common denominator. Okay. All right. Here's something that I'm going to do. I'm going to put my x in front. So I'm going to take out a negative sign and make that x minus 2 right there. And you'll see why I'm doing that here in just a minute. Just trust me for a second. That's going to make your life easier here in just a minute. Okay, so now I've got a fraction being divided by a fraction. So jump all the way back to Algebra 1, and we're going to keep it. Change it. And flip it. And when you flip it, don't forget to flip that upside down. Keep it, change it, flip it. Right? Do you see now why I changed that 2 minus x into negative x minus 2? Okay, because what's going to happen with my x minus 2's? That's right, good, cross them out. Good. All right, so that's going to give me negative 1 over 2x. Okay, so now I can jump back up here where I have my equals and my limit and say negative 1 over 2x. Okay, so originally, if I had plugged my 2 straight in, I would get 0 in my denominator right there. Do you see that? Okay, but now if I plug the 2 in, will I get 0 in the denominator? No. Okay, so let's go ahead and do that. So now I can say that it's just equal without the limit because I'm going to plug in. So 2 times 2 down there on the bottom, and my answer is negative 1/4. So once you plug into the limit, then you can say that they're equal. Questions on that one? Okay, last one, number 9. All right, if I plug in negative 2 to what I have there on number 9, will it give me a 0 in a denominator? It's a trick question. No, because I don't have a denominator, right? There is no denominator. Okay, so when you're given something that doesn't have a denominator, you can just plug directly in. Now be careful, because I've got some order of operations issues here. I like that they put this one on here, because it gives me a minute to talk about order of operations. Okay, so if you can plug in and it doesn't give you 0 in the denominator, go with it. Just plug it in. Okay, you don't have to worry about the graph or the table or anything. Just plug it directly in. Okay, let's talk about order of operations. So order of operations tells me that I need to do my exponent first. So that's going to give me negative, and I'm going to do negative 2 squared, which gives me 4 plus 4. Okay, so watch out for that. All right, then what's negative 4 plus 4 going to give me? 0, that's right. So it's okay to come out with a limit of 0. It's just not okay to have 0 in a denominator. Do you see the difference in those? Okay, by the way, the function value on this one would also be 0. Okay, any questions? Okay, go find your 5.2.1 homework. And I want us to look at a couple of these together. Find your 5.2.1 homework. It looks like this. Okay, so I want you to take a couple of minutes and work together on number 1. So see if you can figure out the limits, the function values. They work with different x values. Remember that your answers are y values. Your answers are always y values. Okay, so take a couple of minutes and work together on that one. Quick. All right, so for 1a, you should have gotten 1. For 1b, we should have gotten 2. For 1c, we got 2. For d, we got negative 1. Since they're different, my limit does not exist. But my function value is 1. And then g is 1 as well. Okay, any questions on that one? Okay, let's jump down to 3 because on 3D, something funny happens. So try 3A through C, and then we'll come back together for D. D, yeah, so try 3A through C. Try number 3, A through C.
Yeah. 3, 1, 2, or 3?
3, 2, I got 1. Would you do 2? Did you do 2?
Oh, that's a 2.
All right, check yours on 3A through C.
Doesn't exist.
All right, now here's what happens. Look at 3D with me for just a minute. Look at 3D. All right, 3D, we're looking for a function value, so a solid point at an x value of 2. Do you see one? No. Okay, so that is what they call undefined. Okay, so that's a little bit different from our D and E. So it's not that this one does not exist. It's what they call undefined. Okay, so there's a little bit of a difference there. If there's not a point at all, they call it undefined. Okay, so I wanted to make sure that you had that verbiage when you're answering their questions.
What is D and E?
D and E does not exist. So like if you're looking at your limit and it's going from the two sides, it hits a different, that does not exist. Whereas undefined is going to be if there's not a solid point. So that's the difference there. Good. Okay, all right, let's look at E. All right, look at E. So where x is equal to 3, which y value are we approaching? 1. Good. Okay, and what's our function value at an x value of 3? 1 also. Good. Okay, so sometimes your limit and your function value will be the same. That's okay. Sometimes they're different. That's okay too. Okay, any questions on the graphs? Okay, flip over and let's take a look at a couple of these on the back side. We've done some of these already on your exploration, but let's take a look at a couple of these just to make sure we're good to go. All right, so let's start with number 5. Okay, on number 5, if I plug in 1, will it make my denominator be 0? If I plug in 1, will my denominator be 0? No. Okay, so since it doesn't give me 0 in the denominator, I can just do a straight plug in here. So I'm going to go 1 squared plus 3 times 1 plus 2 over 1 minus 5. Okay, so since it didn't give me 0 in the denominator when I plugged in my 1, I can just plug 1 straight into my function. I don't need to try to factor it, cancel things out, just plug straight in. So don't make it too hard on yourself. All right, that's going to give me 1 plus 3 plus 2 over negative 4. So 6 over negative 4 gives me negative 3 halves. Thoughts? No, that's when you need to factor them, see if something cancels out. If it doesn't, look at your graph. Yeah, look at your graph and see where it's going. Sometimes, and I'd even say like most of the time, it's D and E, but just check on your graph and make sure. Yeah, good. All right, let's jump down to number 11 because I thought 11 through 14 were kind of hard with these fractions down here. So let's jump down here to number 11. Okay, similar to the one that we did on the exploration again, but I just wanted to make sure that we've seen one more of these. Okay, if I plug in 0, do I get 0 in the denominator? Yes. Okay, so I need to do a little bit of work first. Okay, I'm going to put this 1 right here over 1 so that I have a denominator there, and I'm going to use smile. So I'm going to jump right down here, and I'm going to do top times bottom gives me 1. And then let's think about this as a negative 1 multiplying here. So I'm going to have minus x minus 1. And then when I multiply on the bottom, I'll have x plus 1 over x. So let me stop and let that sink in for just a minute. Okay, so I did top times bottom. And I looked at that as a negative 1 and did bottom times top. And then I multiplied x plus 1 times 1 on the bottom. Okay, let's let my 1's cancel out here. So that's going to give me negative x over x plus 1 over x. Okay, now let's use our keep it, change it, flip it trick. So keep it, change it, and flip it. Don't forget to flip. Okay. what's going to happen to my x's? That's right, cancel out, good. Okay, so that's going to leave me then with negative 1 over x plus 1. Okay, so now let's jump back up here, and now let's look at our limits. All right, so that's going to be negative 1 over x plus 1. Right, now if I plug in 0, do I get 0 in the denominator? No. Okay, so now I can plug in negative 1 over 0 plus 1 gives me negative 1. Yeah.
So on the first part, you put x minus x. No, those cancel.
X minus x. Where am I? Right here?
Yeah.
It was a 1 minus x minus 1, and then I used my line to cancel them out.
Oh, okay.
I canceled out my 1s. Sorry. It does look like an x right there. Let's see here. Let me redo it with a highlighter.
Oh.
So it started off as that. There we go. Then I let my 1s cancel out. Root, like that, yeah. Good question. Sorry. My chicken scratch. Okay. Okay, so your assignment for today is to try the rest of these limits. Give those a try. You've got some of the answers there, but I'll put my key out here if you want to finish those up. And then let's go back to the graphs from equations and try just a couple of those. Okay, so back over here on 5.1.1, let's try 27 and 30. Okay, so on this one, do 27 and 30. And then finish up 5.2.1.